So after doing our little bit of review, that stuff that we actually learned in lesson 8.1, now we're going to go on and we're going to talk about a couple of different things today. And the main thing is the zero of a quadratic function. Other functions have zeros, but we are specifically zoning in on the zeros of a quadratic function. So when we talk about the zero of a function, this does not matter which function it's for. In reality, it could be for any function, this definition. The x value that makes the function equal 0. Doesn't that make sense? 0, it would make the function equal 0. So in other words, when you put something in for x, it's not saying x has to be 0. It's saying that whatever you put in for x, and you find the y value for your table, let's say, it better turn out to be 0 if you're going to claim that x value to be a 0 of the function. So it's kind of confusing because you feel like, well, does that mean that x has to be 0? No. It can be, but it does not have to be. It has to make the function equal 0. So tell me, would, in the parent function, would 0 make the function equal 0?
Yes.
If we put x, 0 in for x? Yes, it would, because we would put 0 in for the x, and 0 squared is 0. So the 0 of the parent function would be 0. It's the x value that makes the function equal 0. For a quadratic function, now we're zoning in on just the quadratic function. Here's the possibility. There can be 1, 2, or no zeros. 1, 2, or no zeros at all. But those are the only possibilities. To find them on a graph, here's what you're going to look for. You're going to look for the x-intercept of the function. So you have a graph, you can look at it and you can say, where is it intercepting the x-axis at? What is the x value there? That would give me the 0. If you don't have a graph, you know how to find x-intercepts. You know that you put 0 in for y and solve it for x. Well, you don't really know how to solve quadratic functions yet, though, so that's going to be a little bit difficult at this point. So hopefully today they're only going to make you use the graph to do it. So let's go to page 531 in your books. If you're not there yet, let's get there. And we're going to do the check it out problem, little 1a. Now, I am counting on you, even though I'm not making you SQ3R at this point anymore, because first of all, we're cruising along. It is spring. You only want to do the homework you have to do. But I am expecting you to at least study these lessons and read them and glean information from them without writing it down. Can you do that for me? Or do I have to have you start SQ3R again? Oh, you're good. You can do that? Okay. So, 1a. The directions say find the zeros of each quadratic function from its graph. Check your answer. Well, if there are no zeros, there won't be anything to check. If there's 1 0, there would be 1 check problem. If there's 2 zeros, there would be 2 check problems. Okay, let's look at that first one. Do you think you know the 0 of that quadratic function in 1a? You have to be looking at page 531 or you'll never be able to answer this. At the bottom of the page, 531, 1 little a. What are the zeros of that quadratic function, Dylan?
I don't think it has a 0.
You don't think it has
It's
any?
not crossing the x-axis.
It has no x-intercept, does it? It's not crossing the x-axis. If it's not crossing the x-axis, it can't have a x-intercept, it can't have a 0. So since the parabola does not touch or cross the x-axis, there are no zeros. Well, if there are no zeros, there's nothing to put into the quadratic function to see if we get 0 for y. So we get to stop on that one. Okay, 1b. What do you think? Do you think there are any zeros for 1b?
Yes.
How many?
1.
1. Oh, only 1. Okay. In other words, the parabola is touching the x-axis. At what order to pair them?
3, 0.
3, 0. And that 3, 0 just happens to be its what? It's its x-intercept and its vertex, isn't it? It's also its vertex. So what appears there is you already told me you think there's only 1 0. Well, then what is it?
The x-intercept.
Up above. Up above. What did I say a 0 is? You know. The x value of that
Makes the function equal.
makes the function equal 0. That's the same as, let's go back up there.
Zero.
Let's go up there and revisit that just for a second. It says right here, the x value that makes the function equal 0 makes the function equal 0 is the same as saying your y value is 0. When you put that value in for x, you're going to get 0 for y. Well, what's true about this ordered pair?
Y is 0.
The y is 0. What's the x value that made that 0?
3.
3. So the 0 is 3. The 0 of the function is actually 3. The number that makes that function equal 0. So now to check it, we put that value in for x and we make sure that's what happens. So we put 3 in for x in both places. Three squared is 9. I can change this to add the opposite, and I have plus a what? Negative 18. I can add any order I want, can't I?
Yeah.
I'm thinking I want to add these 9s together and say, oh, I got a 18 there, plus a negative 18.
Zeros.
Yeah, you do get y equals 0, don't you? So 3 checks out. 3 is a 0. Okay. If we had found 2 zeros, we would have 2 check problems here. We'd have to put each of them in and make sure we get 0 both times for y. Okay? So let's make an assumption here. When there is only one 0, it is the what?
Vertex.
It is the vertex of the parabola. It will come from the vertex of the parabola. Because the vertex is the only point that does not have another point that has the same y value, right? Isn't that what we said earlier in our little review? Okay, so when there's only one 0, it is the vertex of the parabola. So in other words, the vertex has to sit on the what? X-axis.
Oh, I was close.
It has to sit on the x-axis. So maybe you have a parabola that's doing this. Maybe you have a parabola that's doing this. No, that's not going above, but I mean, it's sitting on the x-axis. Okay? When there are 2 zeros, what do you think is happening? I don't want you to try and fill in this blank. I just want you to tell me, what do you think is happening? Let's picture a graph. If there are 2 zeros, what would be happening on the graph?
Means that, like, the vertex is up here, and so there's 2 points in the line that cross the x.
Oh, so if you had a parabola opening down and the vertex was up above the
On
x-axis.
the y, yeah.
So I think this is what I'm hearing John say. So he says, if you had a parabola and its vertex was maybe like up here,
Yeah.
above the x-axis, and it was opening down, would it cross in 2 places?
Yeah.
Would it have to?
Yes.
Yeah. How about one that's opening up then?
We have to be
Where would its vertex be?
in the negatives.
Below the x-axis. So if we had one over here, let's say, oh, I'm just going to put it right on the y-axis.
Oh.
What if it was here and opening up? Would it cross in 2 places? Yeah, there's 2 zeros. Okay. Well, anybody think they have a picture of no zeros? What would it look like then if there were no zeros?
Straight line.
What would that look like, John?
If you,
I think we had one already, didn't we?
yeah, if it opens up and it's above the if it's above the x-axis.
If its vertex is above the x-axis, ladies, if its vertex is above the x-axis and it's opening up, is it going to ever cross the x-axis? No, it can't. And in fact, is that what our picture was for that one? No, this one was what? It was opening down and the vertex was below the y-axis. So there's 2 situations. If it's ever above the x-axis, oh, you just like to look at your pencil? Okay.
Yeah.
If the vertex is ever above the x-axis and it's opening up, it can't ever come down across the y-axis, the x-axis. If its vertex is below the x-axis and it's opening down, it can't ever change and just all of a sudden come back up and cross the x-axis, so then there'd be no zeros. Okay, well, here's the deal. If you have to find the zeros and they don't have it identified, the vertex identified on the graph for you, and they don't have the vertex identified on the graph for you, to make sure that you have the right one, you want to make sure that you do it mathematically. Anybody think they know how we can find the x value of the vertex if we know both of the zeros? What would you do?
Put it in the equation.
Okay, what equation? Our quadratic function one, our ax squared plus bx? Would that give us the vertex, do you think? I want you to look at, let's look up above in the example box. I want you to look up above at example 1, capital A. Would you guys look at that graph, please? Example 1, capital A. Would you tell me, they don't identify the vertex, do they? They don't even put a point there, but is there a vertex?
Yes.
A parabola has to have a vertex, does it not? Okay, what do you think is the x value of that vertex?
About 1/2,
About 1/2?
so it looks like.
So it looks like, okay. Well, can you tell, do you have a better idea of what the zeros are?
Yeah,
What are the zeros?
they're -1, 0, and 2, 0.
Remember, the zeros are just the x values. Come on, class. It isn't just John and LeGrand today. -1 and +2 are the zeros. And the vertex, John says, it kind of looks like it's maybe about the x value of the vertex is about 1/2 is what he's predicting. How could we do that mathematically to find out for sure? What's true about the vertex between any pair of points that are symmetric to each other? It's the middle, isn't it? It's the middle. So it should be halfway. So the x value of the vertex should be halfway between the zeros. When there are two of them, the x value of that vertex should be halfway between those zeros. Let's try and see if that works. Halfway. Okay, how many units of distance are there on that graph between +2 and -1? How many units of distance? There's 3 units of distance. What's half of 3? 1.5. Oh, okay. So now would you take it and go 1.5 units? What's -1 plus 1.5? 0.5. What's 2 take away 1.5? 0.5. Oh, sounds like it is 1/2, isn't it? Okay, so that's another important thing that we want to remember, that when there are 2 zeros, it's crossing in 2 places, all we have to do is take those zeros, add them together, divide by 2, and we will have, what's -1 plus 2? 1. What's 1 divided by 2? 1/2. Yeah, 1/2. Okay. So let's go to the back side. Again, I'm just kind of highlighting some things. You really do need to read through this section because it's got a lot of important information in it. Okay, a vertical line, we already know this. A vertical line that divides the parabola into 2 symmetrical halves is the axis of symmetry. Axis of symmetry. It's a vertical line. A vertical line has its own equation. Anybody think they remember the equation of a vertical line?
Isn't it x equals 0? Or no?
Can be x equals 0.
Which is x, but
It's x equals a number. The number that all the points on that line have in common. They all have the same x value on a vertical line. They all have the same x value. So the equation of that line is x equals that number. What's that number they all have in common? So if it happens to be the y-axis, what do all the points on the y-axis have for an x value? 0. So the equation of the y-axis is really what then? X equals 0. Okay? So what else can we say about the axis of symmetry? It always passes through the,
vertex.
it has to go through the vertex. It divides that parabola in 2 symmetric halves. It always has to pass through the vertex. Every quadratic function has a vertex. And we can use either the vertex or the zeros to find our axis of symmetry. Okay, now, I'm going to also give you another way. We can use a formula that we're going to use down below, and this is it right here. X equals the opposite of the b value divided by 2a. Now this is only useful when we have the function, so we can identify an a and a b. If we have a graph, we can't really tell what the a and the b are. So we use this when we don't have a graph, and they give us the equation instead. Okay? So let's do it with the graphical first. So everybody on page 532, 2a. If we can tell what the vertex is, we're going to use that to help us get the axis of symmetry. What's the vertex for 2a in check it out problem in the middle of the page about? Or is it at the bottom?
-3, 0.
Where is 2a?
It's
That's the
at the
bottom,
bottom.
sorry. Okay. So what's the vertex?
-3, 0.
-3, 0. Okay, then what's our axis of symmetry?
Is x equals -3.
X equals -3. X equals, would you write over my x? X equals -3. It is not just -3, you guys. It's an equation for a vertical line. X equals -3. Okay? So that's when we can tell by the vertex what the x value is. We can tell, we don't have to guess. I'm going to guess that you didn't have to guess. Did you? Was it pretty clear cut? Okay. So then we can just get it. What if they don't identify the vertex for us, or it's not a nice, doesn't look like a nice integer value? Then we better be careful. So in 2b, I want you to tell me what the zeros are.
-2 and 4.
Pretty soon I'm going to cut John off from talking because none of the rest of you do. The zeros are what?
-2 and 4.
-2 and 4. They agree with you, John. That's good. Okay. The zeros are -2 and 4. Find the x value halfway between these. It's going to be 1. How can we do that mathematically? Add them together and divide by 2. So what's -2 plus 4? 2. What's 2 divided by 2? 1. So our axis of symmetry is x equals 1. Again, it's an equation, not just a number. It's an equation, it's a vertical line. Okay, anybody got questions about finding the axis of symmetry using the graph? Okay, if a function has no zeros, well, remember we said that's a possibility. Or it is hard to identify them from the graph, we can use that formula way. Or like in this case, in 3, check it out on page 533, they give us the quadratic function. Did they give us a graph, by the way, for that one? So this is what it's in the middle of the page. Is there a graph for this one?
No.
No?
They just gave us the quadratic.
They just gave us the quadratic function, that's all? Okay, well then we're going to have to use our formula. Unless you guys want to graph it. Do you want to graph it? Anybody want to make a table and graph it? Oh, okay, then we'll use our little equations. Our little formula. What is our A value?
2.
2. What's our B value?
1.
1. We don't really care about C this time. Because we're going to use our little formula here. X equals the opposite of B divided by 2A. So X equals the opposite of B is 1
Divided by 2.
divided by 2 times 2. So that becomes X equals -1 4. Yes, don't.
Wouldn't you be able to also switch that over and just have +4? Or is that not a thing?
Make it a +4. You mean 1/4 make it a +4?
That would be 4.
No. That would be if 4 was upstairs and 1 was down. And then we could, but this way we can't.
Well, no, I was thinking because like.
That's like, what do you want?
Yeah, that's what I was thinking, but
Yeah.
I'm
Yeah.
not just being weird.
Okay, so the axis of symmetry is x equals -1/4. That would have been one of those that it would have been hard to tell on the graph. because 1/4, negative 1/4 could have just as easily been negative 1/3, could have just as easily been negative 3/8, you know, it's hard to tell. So we want to make sure that sometimes we can, to make sure we get it exact, we use our little formula. Okay, questions at the moment?